Hurricane Delta, running through the last 30 hours of infrared animation. You can see that the storm is not quite forming an eye yet. Only in the past 4 or 5 hours have we seen a definite eye on infrared. You can see it popping up right in that area. One other issue is the storm is not very symmetric. Notice how the bulk of the cold overcast is on the west side, and there's not very much on the east side. We can drill down a little bit further using the Dvorak imagery. This simply separates the color bands into a different pattern. This uses a set of infrared curves developed specifically for the Dvorak technique. So we've got about 3 or 4 hours of animation. We'll run that forward. And there you can see the eye coming together. It kind of goes away, and bring that up to the current time, and you can see the warm tops on that side and the cold ones on the other side. So where does this fit in? Well, we can reference the Dvorak chart. You can see it there on Wikipedia. It does take a little bit of experience to understand how to use this, but we're basically in the 4 to 5 range. And you can see when you get up to levels 6 to 8, the patterns are much more symmetric. Now, these do not correspond to Saffir-Simpson categories. Those are totally different things. But using these T numbers, you can map that to intensity. And that gives you a rough estimate as seen here. And to a certain extent, this is empirical. But you can see that 4.5 to 5, which is where I think we are about right now, that puts us in Category 1 to Category 2, maybe 3. Certainly by the intensity estimates, as we'll see shortly, going by that alone, we're kind of in that range right there, which is around Category 3. But let's look at that. There's the map, and the official estimate has 90 knots sustained with 966 millibars. And I always like referencing this chart to make sure that I'm getting this right. That puts us in the middle of the Category 2 band. And we have a northwest movement at 11 knots. And let's check out that forecast track. There's been a couple of changes. One is the very slight westward movement of that forecast track, and we're not going so aggressively with major hurricane development. One little mark there of Category 3 strength, I'm assuming Category 3, and then we've kind of made it clear from the very beginning that as it approaches the coast, there should be some weakening due to the poor ocean heat content. And without that, the convective processes, the latent heat, warming, all of that tends to subside and allows filling of the storm, which means weaker winds. But there certainly will be a risk of storm surge, still holding that 7 to 11 foot forecast, and that is going to have a significant effect since this is all low-lying terrain. Fortunately, not any large towns in the way. However, Lake Charles, this is becoming a little bit more under the gun. Now, they are about 30 miles back from the coast and about 10 miles from this Calcasieu Lake. So most of the serious storm surge should affect this area right here. And there's only one little highway through there, a couple very small towns, a smattering of houses, a lot of them on stilts. So very likely there will be some damage, especially around some of these small populated areas. However, the effects in these densely populated areas here should focus on the winds as that storm rapidly moves inland, and also localized flooding. The maximum wind gust, this is a great product from wxcharts.com. This is the cumulative maximum wind gust, and we're looking at the GFS model. So what we see here is that winds along the coast, not surprisingly, pretty uniformly up in the 80 to 90 mile an hour range. Inland about 30-40 miles where the populated areas are, we're looking at about, looks like about 90 miles an hour on the right side track, very clear distinction between left and right side track, and on that left side track where you have the motion subtracted from the wind speed, it's more on the order of about 60 to 70 miles an hour. So with a fast-moving storm like this, I think it can bring the wind field pretty far inland, and it looks like some of the damaging wind speeds will extend inland about 50 to 100 miles or so. And then that should decline substantially as it moves into northern Louisiana. With the ECMWF model, the European model, we don't get a cumulative wind gust, we just get instantaneous readings, but we'll check that out anyway. Looks like this model is going a little bit more severe with the winds. A lot of places on the coast, 160 kilometers an hour, which is going to be about 110 miles an hour, extending inland somewhat. And Lake Charles pretty uniformly in the 120 to 130 range, which is about 80 to 90 miles an hour. And the European model bringing in damaging winds pretty far inland, all the way into southeast Arkansas. And you can see winds there, 110 kilometers per hour, which is about 70 miles an hour, all the way up into this range right here. So there's very clearly disagreement between the models on the wind field. The European model appears to be exceeding the NHC forecasts, and I think it may be overdoing the situation. However, I think the extent of the wind field coming inland will tend to take people by surprise. But looking at those NHC intensities, I certainly trust this product. I know a lot of people on YouTube, social media, they claim to be experts, that kind of thing. I don't think I'm a great tropical cyclone expert. My specialization is mostly in severe weather, convective weather, mesoscale analysis, some numerical forecasting, that kind of thing. So I do put a lot of stock into this product, and I see no reason to contradict it unless I'm seeing something that's not meteorologically consistent. And that's the kind of thing a forecaster needs to know how to do. And this all looks good, and we see it increasing to 100 knots. That's low-end Category 3 tomorrow morning. That's a little ways from the coast. And then by the time it's on the coast, you can see 90 knots, which puts it in the Category 2 range, right in the middle, about where it's at now. So there's not going to be catastrophic winds coming inland, anything like that. But keep in mind, yes, there is a significant storm surge, and due to the rapid motion, the wind field could be carried inland a little further than what people may expect. So the next question is the track. What you're looking at here, this is yesterday's official track from NHC, that thick line right there, and the forecast guidance right here without the ensemble members. So you can see NHC was leaning a little bit to the west, and we were focusing on this area. We were looking at some street view, checking that region out. And Lake Charles, yeah, they had the possibility of escaping the eye wall effects, but as I said yesterday, we were just going to have to wait and see on that. Well, if we look at today's track, I'm going to plot that in red, you can see the shift to the west. So we've gone about 20 miles to the west, and you can see that's away from the guidance that we had yesterday. Now, I think a very important thing to look at is which members of the numerical guidance got this westward shift correct. Well, we've got a couple marks out here. This is the Canadian Meteorological Center interpolated. Yeah, some of the CMC stuff went a little bit far west. The GFS ensemble was leaning a little bit to the west also. And the TVCX, which I'm thinking is probably one of the better consensus models. So we're going to look at that. So let's fast forward to today. So we've got the same bundle of guidance as the one I showed you yesterday. And what we see here is some of the members are kind of converging on this western track. They've all shifted west. So let's fish out the ones that did a good job yesterday. The GFS ensemble, well, that's stopped moving to the west, and now we find it east of the official track. The TVCX in green, that pretty much falls right in line with the official track. And zooming this in, who's still leaning to the west? One of the Navy models, some of the CMC guidance still leaning west. Similar situation to yesterday. So I don't know, we could be done with the westward jogs, but there's still a little bit of uncertainty. And the reason that we're having this problem is because it can be difficult finding what the steering layer is, how deep we're going to go in the atmosphere. The storm is pretty much carried forward by a combination of the convection going on in the storm, plus the deep layer flow that it's embedded within. Now, it can be hard to establish which vertical layers to take into account, and that leads to some uncertainty, which is kind of what we're seeing here. But I think with the storm being less than 36 hours away, we're pretty much converging on the final solution that you see right here, which so far passes within 18 miles of Lake Charles. So yes, Lake Charles is going to be within the eye wall, although the wind field on the left side of the storm should be a little bit weaker. The heavier effects will be around Grand Chenier and just east of there on Highway 82. And most of this is all wetland. Most of the populated areas are found at least 30 miles inland, and the storm surge should not be a problem that far north. And the latest on Delta, this just came in, 100 knots. So we're up to Category 3 strength, and this is a little bit faster than had been forecast. So yep, we're pretty solidly in the Category 3 range through tomorrow. And then we're still going with some slow weakening during the day, probably down to a Category 2 for landfall. There's the surface map for this afternoon in the southeast U.S. I do find that stationary front across Florida separating this very warm, humid air mass in southern Florida from the stuff in Georgia, Alabama, where it's more mild and the air is drier. Hurricane Delta, it's actually located right about there. This is probably not the isobar field you would expect. Typically, we see kind of a spider web of isobars, and the reason for that is we just don't have a whole lot of observed data in the Gulf. I mean, I don't think any of us would want to be on a ship close to that thing getting measurements. So it's possible we can start bogusing in some of that data. If we continue to have an active hurricane season, I'll probably rewrite this program to get us better plots in that region. In fact, I may see if I can do that for tomorrow's show. No guarantees. In Texas, that dry line we had yesterday, I've decided to remove that because the wind flow is not so convergent. We've got southerly flow in the Panhandle, southerly flow in Oklahoma City, so we're really not bringing those dew point contrasts together, and we just have a gradual drawing up into the higher elevations. The satellite at this hour is showing Hurricane Delta down there in the western Gulf. These are not outer spiral bands. These are convective cells along that stationary front. The actual spiral bands with the convective cells, those are going to be right here. That's a kind of a very small one. And then we pick up more as you get closer to the storm. So I think we're about 12 to 18 hours, maybe 9 to 18 hours before those coming on shore. And then we have this other convection up there in Louisiana, East Texas, but I think that's more associated with the deep moisture surge and maybe a little isentropic lift over the front. And we are picking up some of the outflow cirrus. You can see that right there. Let's take a look up north. Our poor viewers in the northeast being neglected due to all the action in the Gulf. And, yep, more cold air advection, stratocumulus. That's implying flow like that. You can see the transverse waves across the mountains of New York and New Hampshire, Vermont. Some of those cells are built up pretty good around Toronto, London. And there they are in the radar imagery. Toronto getting some very blustery weather there. So these cells are going to be topping out probably about 15,000 feet to 20,000. It's basically just very tall, towering cumulus and some mushy, shallow cumulonimbus. There's a surface map for the northeast showing some very cold weather. Lower 40s in upstate New York near Plattsburgh, near Burlington and Albany. Well, Albany's 56, but yeah, this is definitely some very cold weather, probably the coldest daytime temperatures we've seen in this part of the country so far. There's the high pressure driving a lot of that cold air sinking into the Great Lakes region, and as we go out west, we pick up the warm southerly flow, and that's the feed of the warm air mass coming up from the southerly latitudes. I'll kind of scroll that out there, and we can see 80s in Nebraska. So yeah, I should probably look for a warm front. 80 versus 58. Yeah, there's something in there. Let's find that. Okay, let's see. Where does the temperature start dropping? That's going to be in South Dakota, I think. It's a very cool 70 in northeastern South Dakota. So I think I'm going to put that warm front down there and extend that maybe into northern Missouri, kind of like that. So that appears to me to be a bear clinic system. And there's what I'm seeing for the northwestern U.S. If this doesn't make much sense, look for the cold air. 50s and 40s up in Manitoba and far western Ontario. Look for the warmest air. 80s in Colorado and Nebraska. And also 80s, well, upper 70s in Montana. Actually, looking at this looks to be part of the same air mass, so I might actually bring that cold front in Wyoming and connect that up to the Montana system like that. So it looks like two little Alberta clippers working southeast along that thermal gradient. And you can see the cold air up there in Alberta. Very cool conditions, 40s versus almost 80 down in the southern part of the province. As is typical with Alberta clippers, especially when they're dry, you may not see much surface reflection. And I definitely don't see any here. Maybe up in Alberta, but that's off the screen. So that leads me into the western U.S. It looks like it's getting active in the upper levels. See, there's one system right there. We'll take a look at the water vapor imagery. I think that's probably a shortwave working inland. And it also looks active off the coast of Washington. I pulled that a little further to the west so you could see everything going on. Very extensive marine layer just offshore, another frontal system. Way out here, if I can get the colors right. Yeah, I think that's probably maybe running something like that. You can see the more vertical structure on the clouds out here in the warm sector versus the very stratified look along the California coast. As far as that thing right there, let's check out the water vapor imagery. Yeah, you can really see it right there. That's certainly some sort of disturbance. You can see the S shape on the back. The cusp located just northwest of Sacramento. So that's a shortwave moving across the Sierra Nevadas. That's going to be mostly in the upper levels. Let's check that out on the GFS panel. Yeah, it's just barely showing up right there. That's that area of enhanced vorticity. In fact, I kind of suspect it may not have a good handle on that wave. Let's check out the European. So maybe the models are picking up on that shortwave, but I think that maybe they're carrying it just a little bit too far south. And that could have some bearing downstream in the Great Basin area tonight and tomorrow. And there's our map of the southwestern U.S. Heat low, pretty well established. Hot in the deserts, plateau high. And that's about it. You can see there's not much weather in California, so those upper level systems are passing over and not yet really doing much. So that'll do it for this edition of Forecast Lab. Thank you for watching, and I appreciate your support and your comments and sharing this channel on social media. I don't often request that, but if you can do that, that will help more people find us. The YouTube algorithm is not kind to smaller channels, and you can see that by some of the recommendations you get. Most of it is giant channels with 10 million views, and it is very hard for us small channels to get any visibility. So I do count on you to help spread the word. All right, thanks. We will see you tomorrow. Bye-bye.